Sometimes. Yeah. Well, I guess this segment's not this much.
Yeah, I take over. All right, so here we are graphing rational fractional functions. All of these things, of course, you can graph using your graphing calculator. And if you're going to graph them on your graphing calculator, you want to be sure that everything in the denominator gets put inside parentheses so that it is graphed properly, okay? I am never going to ask you to graph a rational function on a test. Ever. Why? Because you have a graphing calculator. Duh. So I'm never going to ask you to graph. Okay? That would be stupid. I am, however, going to ask you all of these things. What are the vertical asymptotes? What are the horizontal asymptotes? What is the domain? What is the range? Where are the holes? All right, all things that you have to know how to do in order to get the answer that the calculator might not necessarily give you, okay? So you have to know all of the parts of the rational function. We're going to use our calculators to help us graph. Maybe not today. Today's quite easy, but we're going to spend the next couple of days on rational functions, and your calculators will be quite helpful.
Today?
It's certainly nice to have out, but you don't need it today. It's super easy today. Today, the work you'll finish like 15 minutes before class.
Thank you so much.
All right. Example 1. Graph the rational function. Graph the rational function. Identify the vertical asymptote, horizontal asymptote, domain, and range. All the important parts. All right, so I have my function y equals 2 over x minus 3, and then subtract 4. Now the h and k perform just like they have been on your graphing projects that you did. The h shifts things left and right, and the k shifts things up and down, and which is kind of interesting. But before, we want to find out what is the domain. X cannot equal 3. That is correct. A denominator domain that always comes from the denominator. X cannot equal 3. And if you know that, then we also know the vertical asymptote. What's the equation for the vertical asymptote? X equals 3. It's like a 2-for-1 deal. I love those. I'm all about the 2-for. All right, so, but please, ladies and gentlemen, do not just put 3. The vertical asymptote is the equation of a line. 3 is a number. But when we attach the x equals in front, that means, hey, x equals 4, that is the equation of a line, or in this case, x equals 3 is the equation of the line. That we get close to but do not touch. Now, what is the horizontal asymptote? Y equals -4. The thing that's added or subtracted on the end is the k value. And again, that is something we are going to graph as a boundary line. It creates boundaries for us to graph in between. And then if we know that that horizontal asymptote is y equals -4, then I also know the range is that we're not going to have y values of -4 either. That doesn't always happen. Range is kind of tricky. But for these simple rational functions, it is always true. All right, we're going to go ahead and make an easy sketch here. Let's see. My vertical asymptote is x equals 3, 1, 2, 3. And it is a vertical line. And you're going to label it x equals 3. And then we have our horizontal asymptote at y equals -4. 1, 2, 3, -4. Y equal, it helps to do the okay. And so basically create these regions. And this is where I get my math gang signs from. These rational functions, just slightly throwing signs at each other. Okay. Rational functions. Okay. All right. So now to actually do some graphing, we are going to do a little XY chart. Turns out to be really, really easy. I just need a few points on the graph. That is all. To figure out what X values to use, you're going to use X values to the left, one value to the left, and one value to the right of the vertical asymptote. What's the value to the left? 2. What's the value to the right? 4. 4. Yeah, 4, not 3. 4. All right. So I'm going to take 2 and plug it into my function. 2 over 2 minus 3 minus 4. What's 2 minus 3? Negative 1. What's 2 over negative 1? Minus 4? Negative 6. So my ordered pair that I'm going to graph is 2, negative 6. 1, 2, 3, 4, 5, 6. Right there, plot the point, and I'm going to label it to negative 6. These are the little L shapes. They get close to those asymptotes, but do not touch, okay? I'm going to plug in my X value of 4. So, and again, this is stuff you can do in your head. So 4 minus 3, 1. 2 divided by 1. Minus 4, negative 2. So I have the ordered pair 4, negative 2 right there. Plot it and label it. And again, we get this L shape that just gets close to those asymptotes. That's the graph. Those are the little L's. All right. There is a relationship between the A value of 2 and distance from this intersection of our asymptotes. All right, did you see that? Can't really tell on here, but look, it's kind of like slope. Kind of, rise over run, but it's not slope. Don't confuse myself. But look, it's up 2 over 1 is 1 point, and then in the other direction also. Okay? So that number on top does help us graph as well. I prefer just X and Y. Now, of course, you can check all of this in your calculator as long as you know how to plug it in. Please, please, please put parentheses around your denominator. And of course, you could use your calculator instead of making your XY chart by hand. Could you use your calculator? Absolutely. Because you can plug in the equation, and if you wanted to label a point, you do trace 2, and it would spit out negative 6. And you can trace 4, and it would spit out that negative 2. What's going to happen if I tried x equals 3?
0.
Is it 0? It's undefined. It is not defined. There is no point there. It's undefined. And that's where that vertical line comes into play. There's nothing graphed there. All right. Letter B. Letter B. What is the domain? X cannot equal 0, which means the vertical asymptote is X equals 0. I'm going to graph that. And what is our horizontal asymptote? Y equals 0. I'm going to graph that, which if we have a horizontal asymptote, the range then also says Y cannot equal 0. Very good. All right, very easy. So I am going to graph the vertical line, the vertical asymptote, X equals 0. Isn't that interesting? X equals 0 is the equation of the y-axis. Is that weird to anybody else? Yeah. Have I talked about why this equation makes perfect sense? Okay. Yeah, you had me last year, must be. Huh? What's the ordered pair for this point right there? 0, 1. What's this point? And this point? 0, 3. And in fact, every point on that vertical line has what?
0.
A 0 for x. Like the x coordinate is always 0. Oh, that's. Do I care about the y coordinate? No, it could be anything, but the x is always 0. Always. That's why those equations make sense. All right, very good. The same is true for the equation of a horizontal line. Same thing works. They're useful things to think about. All right, and then I'm going to go ahead and make a little XY chart. How do I know what values for x to use? One to the right and one to the left of our vertical asymptotes. So -1 and +1 would be good choices. If I plug in a -1, what's 3 over -1? -3. So I have -1, -3 as a point. If I plug in a +1, 3 over 1 is 3. So I have the ordered pair 1, 3 to label. And make the little L shapes. All right, that's it. Do you have any questions for me? Look at that, 11 minutes and 49 seconds.
That's
Yes, I wish I listened to